Moving on to our second example, and this one is pretty clear. You'll notice we have a very elongated hodograph in the mid and upper levels of the atmosphere, drawing in our storm relative wind vectors above 6 kilometers, and you can see that they are quite lengthy, especially that 8 and 9 kilometer vector, well in excess of that 40 knot threshold for LP supercells. That 6 kilometer vector, only about 25 to 30 knots or so, but above that, a deep layer of storm relative winds in excess of 40 knots. And we shouldn't have any issues with precipitation being shunted ahead of the storm motion and the mesocyclone region of the storm. If we do our technique drawing in the supercell shape around the hodograph, you'll see that precipitation, all that precipitation should be vented well away from the mesocyclone region of the storm. So our wind profile certainly suggests that low precipitation supercells will be favored in this environment. We also have a fairly dry environment, lots of dry air above about 850 millibars or so, precipitable water values below 1 inch, and we have a little bit of capping to work with, a little bit of a warm nose there. All of these signs point to a low precipitation storm mode. And sure enough, this was a proximity sounding to a beautifully sculpted LP supercell near Dora, New Mexico that actually produced a tornado on May 26, 2019.
Subscribe to the best deal in storm chasing. Chaser Academy, link in bio.